Okay, welcome back, everybody, to another topic. Today's topic is solving right triangles. So, at the end of this lesson, we should be able to solve right triangles, which means to find all their missing angles and all their missing sides. Before we do that, though, we're going to have to learn a little bit about our calculators and how to find angles. So, we're going to need inverse trig functions to do that. So, inverse trig functions, look at the text here. Inverse trig functions are used to find angles in right triangles. So, notice how it's the exact reverse of what you do when you find the sine, cosine, or tangent of an angle. If we know the sine of 42 degrees is 0.669, then the inverse sine of 0.669 takes you back to 42 degrees. So this little -1 here looks like an exponent. It's actually not an exponent. It's just a notation to find an angle whose sine is given. Let me say that again with the cosine. So let's say we want the cosine of 87 degrees. You put that in your calculator. You'll get a decimal 0.0523. And then if you want to go back to 87 degrees, the inverse cosine is 0.05, the inverse cosine of 0.0523 is at 87 degrees. On your calculator, and I'll do this on the Google calculator, but on your calculator, you're just going to have to find the second key or the inverse key to help you do the inverse function. Likewise, it works for tangent. So if you want the tangent of 37 degrees, that's 0.7536. And then to go back to 37 degrees, you're going to take the inverse tangent at 0.7536 to get back to that 37 degrees. Okay, so to do that on a calculator, first of all, make sure you're in degree mode. This Google calculator starts in radian mode. We're not going to do that this year. We're going to use degrees. So let's say I find the sine of 42 degrees. So just find the sine, 42 degrees. And the calculator gives you a decimal. Now to go back to that 42 degrees, you're going to take inverse sine. So somewhere it'd probably be second or inverse or something. Maybe it's different on your calculator. Inverse sine. And you can see what happens there. That you see that -1 inverse notation there. Inverse sine. And the Google calculator calls it arc sine. It's same as inverse sine. Google calculator is the only one that does that I know of. But I'm going to find the angle whose sine is the one that was just up on the screen. So that's in the answer variable. So if I click on answer there, that's going to take and give me the angle whose sine is that 0.669 that we already found. And that's going to take us back to that 42 degrees. So it just takes you backwards. So the other inverse functions work in the same way. So again, make sure this refreshes, make sure you're in degree mode. There it goes, a little lag there. So cosine of 87 degrees, so cosine 87 degrees. It's going to give us this decimal 0.052, etc. Now, if I want to go back to that 87 degrees, I can, again, just take inverse cosine right there, inverse cosine, and then answer. That, again, puts that cosine back in there. So basically what I'm doing is I'm finding the angle whose cosine is that long decimal. And that'll take us back to that 87 degrees. Let's do that one more time for the tangent and see that it works also for the tangent. Again, when I refresh here, calculator goes back to radians, so I got to change that to degrees. So if we take the tangent of 37 degrees, so tan 37, there's your decimal. Now I'm going to take the inverse tangent of this same decimal. That's going to take us back to that 37 degrees. So again, second or inverse tangent, you can see how that changes of the answer I just got, which is that decimal up there. It's going to take us back to that 37 degrees. Okay, so you're going to use that function then on your to solve these triangles that we're going to be dealing with. Okay, so let's do a problem here. So you see it just says solve the triangle. So again, solving a triangle, it says right there, means to find all the sides and angles of the triangle. So we got options. These are not all done exactly the same way. People are going to take different routes to the same answer. So basically we got to find side B there, which is the hypotenuse. We could do that by Pythagorean theorem if you wanted to. We could also use our new trigonometry. And then we also have to find angle A and angle C. I'm going to find angle A first. because I know the opposite leg from angle A is 5, and I know the adjacent leg for angle A is 7.5, I can use a tangent ratio. So the tangent of angle A equals 5 divided by 7.5. That's what the tangent is. Got to have that memorized by now. So the tangent of angle A, I'm just going to do this on my calculator. 5 divided by 7.5. It's going to be points. I'm just going to round this off, 0.6667. So now I use that inverse tangent. So angle A, so go to your calculator and do inverse tangent, and you're going to get 30, I'm going to call that 33.7 degrees. 30, you know what, I'm going to round that off, 34 degrees. No, 33.7, let's do that, 33.7 degrees. Usually nearest tenth is going to be what we're going to be working with this year. Okay, now I got that, so that's 33.7 right there. Now, I don't have to do any fancy trig to get angle C because I know angle A and C are complementary. So I'm just going to take 90 minus 33.7 and get 56.3. So this angle is 56.3 degrees. Okay, now we got a couple options. Again, we can use Pythagorean theorem to find the hypotenuse. You could also set up a cosine or a sine equation to get that. So I'm going to go ahead and set up a sine equation. So the sine of angle A, but I know that right now, right? It's 33.7. Sine of 33.7 equals opposite over hypotenuse equals 5 over b. And then I'll just solve that for b, and I will have solved my triangle. So that'll give us b sine 33.7 degrees equals 5. Just multiply both sides by b, and then you're just going to divide. So b equals 5 divided by sine of 33.7 degrees. Again, making sure your calculator's in degree mode, go ahead and do that. Make sure you got the keystrokes in the correct sequence, otherwise you won't get the correct answer. 5 divided by sine of 33.7 equals, so b is equal to, I'm going to round that, that's 9, yeah, it's 9 rounded off, so we'll just call that 9. So that side is 9 right there. All right, so there you go. There's one danger I should point out here, that because we rounded off 33.7 degrees, we are now using a rounded off answer to calculate another answer. So it might have been better to use Pythagorean theorem directly, again, because you don't want to use a rounded off answer to get another answer because it just multiplies the error. But for the point of this problem, we saw what we could do if we wanted to. Let's do another one of those, solving the triangle. Okay, again, we got choices. We got to find, let's call this side small r. It's across from angle r. We could use Pythagorean theorem there. We could also use, looks like sine, or we could use also cosine. No, we could use tangent to get that side. Let's find angle r, though, first. So looks like it's going to be a cosine problem, doesn't it? Because so if you're standing right here, let me point at that. If you're standing right here, the cosine, you know the adjacent leg is 5. You know the hypotenuse. So adjacent leg and hypotenuse, that's the cosine. So cosine of angle r is 5 divided by 5.7. Okay, so the cosine of angle r, I'm going to do 5 divided by 5.7 on my calculator. So 5 divided by 5.7 is 0.8772. And even that's rounded off. So angle r, so inverse cosine, 28.7 degrees. So now we know angle r is 28.7. Okay, now we can find angle T real easily. Just subtract that from 90. So 90 minus 28.7, 61.3. So that's angle 61.3. And so we've almost completely solved the triangle. We do need to find side R there. So this time I'm going to use, let's just say tangent, because we know angle R. So we can, and this is not the only way to do this, by the way. Tangent of angle R is tangent of 28.7 degrees equals opposite over adjacent. So the opposite is R, so we have to bring that R into the problem. So opposite over 5. So you kind of got to maybe need to twist your paper around to see that. But if you're right up here at angle R, the opposite leg is R, and the adjacent leg is 5. So let's just solve that. So we're going to multiply both sides by 5. So 5 times tangent 28.7 degrees equals R. And we'll just multiply that out this time. We'll get that third side of that triangle. So I'm going to do the 28.7 tangent first. So 28.7 tangent of that, and then multiply that by that 5 after that. You don't have to do it in the way you see it. 2.7, let's call it 2.7. So now we know that this side is 2.7. Okay, so we've found all the missing sides and all the missing angles in that triangle, so that triangle is solved. Okay, let's do one more. This one's on graph paper, so we have different options. We can just count the sides here of the legs anyway for the sides. So we got 1, 2, 3, 4. So that side's 5. This side is 1, 2, 3, 4. And so we can do Pythagorean theorem. Matter of fact, I think I will this time. I'll do Pythagorean theorem. So 4 squared plus 5 squared equals, let's just call that h for hypotenuse, h squared. So h squared equals 16 plus 25. H squared is equal to 41. H is equal to the square root of 41. So we're going to go ahead and write that as a decimal, 41 square root 6.4. So that side's 6.4. Okay, so the only thing left is to find angle J and angle L, because we know angle K is a right angle. So I'll use tangent. Now you got options, and not only could you could do tangent of angle L or tangent of angle J. Either way, you're going to get one of those angles first. So I'll use tangent of angle L. The opposite is 5. The adjacent is 4. So tangent of L is 5 over 4. So I know that, I'll go in a step. I know it's 1.25. So angle L, so now I'm going to take the inverse tangent, right? So L is the inverse tangent of 1.25. So 1.25 inverse tangent, 51.3. No, that can't be right. Yeah, that's right. That's right. 51.3. That's an angle. I was thinking that's the side. Degrees, and then, so that's that angle right there, 51.3. And of course, we'll just subtract from 90. So 90 minus 51.3, 38.7. So we have solved the triangle. The only difference here, it was on graph paper. Instead, you had to count the squares for your legs. And then we found the angles by inverse trigonometry. And then we found that hypotenuse by Pythagorean theorem, but we could have also set up and used sine or cosine to get that hypotenuse as well. Okay, so there's your examples, and mainly the thing you got to remember out of this is that solving right triangles means just finding all the sides and all the angles. They give you some starting numbers, but you got to find everything else. And you got to remember to use your inverse trig to get angles. And that's just a matter of usually hitting a second button or an inverse button ahead of that sine, cosine, or tangent to get that inverse function. Okay, so these are really going to get better for you if you work some problems. So let's go ahead and try some problems out. All right, good luck.